Hey, is this thing on? What's up, dudes? Crush here. Meet my friends.
Hi, it's Dory.
It's Nemo.
It's Bruce.
Hi, Bruce.
We just rode the EAC all the way to Malibu. Now we're checking out the biochem students at Pepperdine, dude.
Yeah, dude. Today we're going to watch them as they isolate myoglobin using two different lab techniques from tuna fish.
I'm a fish.
Fish are friends, not lab tools. But dudes, when used in biochem lab, use mortar and pestle with liquid nitrogen in order to preserve the primary, secondary, and tertiary structure of the myoglobin protein.
Step 2, I can read. Dissolve powderized muscle tissue in 6 milliliters of extraction buffer by vigorous shaking, then centrifuge material for 10 minutes.
Yeah, it's like the buffer protects the protein more, dude. It's got sodium chloride to control the osmolarity, tris to control the pH, dithiotherol to protect the sulfide bonds, EDTA to prevent oxidation, and PMSF which is the serine protease inhibitor.
Look, we can see them doing all the steps from the fish tank. Look at them go!
We're traveling down to the centrifuge lab.
To take this, so take the supernatant, and we're pouring it out, and that will contain our myoglobin.
Just keep dripping, Big proteins drip out first, small ones drip out last, because they interact with the column pores.
Dory, you can speak whale?
I can speak whale.
It shoots light through it and it measures the absorbances at 280 and 415. And so we're measuring the absorbance. Okay, I'm gonna try 21 there.
And how many fractionations do we have?
We have 50, but I've deduced it down to a range between 10 and 20. And so far, the highest was at 13.
With these different percentages of ammonium sulfate concentrations, they fractionated, centrifuged, and incubated each sample to determine where the myoglobin was.
The increase in concentration of ammonium sulfate attacks water by hydrogen bonding, decreasing entropy. The hydrophobic parts of the protein are then exposed, creating stronger protein-protein interactions, causing proteins to salt out.
Oh my gosh, that guy's touching the butt!
No, Dory, that's a centrifuge.
Now we're going to add 2 microliters of STSS to our 100 microliters of
And we're adding 10 microliters of STS to our 500 microliter ammonium sulfate. They're adding SDS so that when they denature protein, it's linearized, exposing hydrophobic regions that interact with the charged detergent, creating a charge per unit length of the protein that will then move down the electrophoresis gel.
This is my favorite part, dude. They're loading each sample into the individual wells. Bubbles!
my bubbles.
It's working! Righteous.
All the proteins have the same charge per unit length at this point, so smaller sized proteins will move at a faster rate than the larger ones through the electrophoresis gel.
Maybe lean it down.
The E-stain instrument stains each individual protein band using Kumasi blue dye in just 7 minutes, dude.
Did they find your myoglobin, Nemo?
No, there is too much protein, and myoglobin is near the loading diaphragm, so it was not separated enough.
Yeah, and their lower cell had the latter, which failed.
Yup, at least they know their techniques now, and watching science was a lot of fun.
I love watching these kids from the fish tank. They're wicked smart.
Goodbye!
Oh shoot, there she goes again.